Let us continue the problems on bivariate distributions in the discrete case. Okay, we shall consider the problem given f of x1 x2 equal to 1 by 16 for x1 equal to 1 2 3 4 and x2 equal to 1 2 3 4. The question is to check whether x1 and x2 independent. We have already discussed f1x into f2y equal to f of xy for all x and y implies that the variables x and y are independent in the discrete case. Okay, so here we are given f of x1 x2 as equal to 1 by 16 for x1 equal to 1, 2, 3, 4 and x2 also the same values, x2 equal to 1, 2, 3, 4. Let us consider this in the table form, that is bivariate probability table can be obtained as, we shall consider x1 and x2. Okay. X2 takes the values 1, 2 and 3 and 4 and also x1 1, 2, 3 and 4. For all x1, for all the pairs, for all x1 and x2, this probability is 1 by 16. That is for all the pairs f of x1, x2 equal to 1 by 16. Okay. So that I have written for all pairs for probabilities for all xy 1 by 16 each, and hence we can obtain the marginal distributions. Already I have discussed if 1x equal to sigma over y f of xy and if 2y equal to sigma over x f of xy. That is, as x1 is in rows, the row total gives f1x values. Okay, f1x, that is each equal to 4 by 16, which is 1 by 4. And the grand total equal to 1. Similarly, as x2 takes, it is f1 x1 and f2 x2. Okay, f1 x1 and f2 x2. I have written f1x f2y, doesn't matter. So that here it is equal to again the column totals, that is 4 by 16 each and the grand total equal to 1. Okay, it can be written as f1 x1 and f1 x1 equal to sigma over x2 f of x1 x2 and f2 x2 equal to sigma over x1 f of x1 x2. Okay, so that we have obtained the marginal distributions of f1 of x1 and x2. And we have to check whether the variables are independent, that is f1 of 1 into f2 of 1 equal to 4 by 16 into 4 by 16. Okay, 4 by 16 into 4 by 16, it is equal to 1 by 16 equal to f of 1 1. That is 4 by 16 into 4 by 16 equal to 1 by 16 or 1 by 4 into 1 by 4 equal to 1 by 16 equal to f11. That is f1 x1 into f2 x2 equal to f of x1 x2 for all x1 x2. Okay, we will obtain these values for all x1, x2. So that is, we obtain it as the condition is satisfied. So that is x1 and x2 are independent. x1 and x2 are independent. So the first problem is over. Okay. Now we consider the next one. All are written as Yes, it's okay. 4 by 16, 116 cancel, so that it is equal to 1 by 16. So, which is equal to F11. Here the first problem is over. So, let us consider the next one. That is, we are given 2 unbiased dice are thrown. So, we know 2 unbiased dice are thrown. We know the sample space. We can write the sample space. If x is the number shown by the first die and y is the larger of the two numbers, find the joint PDF and the marginal distributions of x and y. The problem is different. Okay, examine whether x and y are independent. That is, when 2 unbiased dice are thrown, we consider the sample space. We have the sample space as equal to, it can be written as 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. That is, if s equal to 1, 1, 1, 2, etc. up to 1, 6, 2, 1, 2, 2, etc. up to 2, 6, 3, 1, 3, 2, etc. up to 3, 6. 4, 1, 4, 2, etc. up to 4, 6, 5, 1, 5, 2, 5, 1, 5, 2, etc. up to 5, 6, 6, 1, 6, 2, etc. up to 6, 6. Now here we have to consider x as the number on the first die. Okay, and x as the number on the first die means x takes the values 1, 2, 3, 4, 5, 6. Now, what about the pairs? The pairs are from 1, 1 up to 6, 6. And what is y? Y is the larger of the two numbers. Y is the larger of the two numbers. That is, if the pair is 1, 1, y equal to 1. But if the pair is 1, 6, y equal to 6. If the pair is 2, 6, y equal to 6. If the pair is 5, 1, y equal to 5, and so on. So, let us consider, it's a challenging one, let us consider the probability distribution. Okay. So, I am considering the table. That is, we have to take x as the number on the first die. So, x 1, 2, 3, 4, 5, 6. Y again 1, 2, 3, 4, 5, 6. Isn't it? For 1, 1, the larger is 1. So, for 2, 1, the larger is 2. That is y also takes the values 1, 2, 3, 4, 5, 6. For 1, 6, the larger of the two numbers is 6. Okay, and not the other values, as the pair takes from 1, 1 up to 6, 6 when 2 dice are thrown. So here we consider x1 means that first row. We can consider, I have already written the sample space. x1 means that the first row. So, y1 means that only the pair 1, 1. So, the probability is 1 by 36. Isn't it? And x1 again, first row, that is 1, 1, 1, 2, etc. up to 1, 6 we have to consider. And the larger is 2 means that only the pair 1, 2. So, that again 1 by 36. Here only the pair 1, 3 means that 1 by 36, 1 by 36, 1 by 36, 1 by 36. Okay, so first row is obtained. And what about the exit 2 means that we have to consider the second row of the sample space. 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6. What is the larger of the values is 1. It doesn't exist. Okay. 2, 1, 2, 2, the larger is 2. That is, larger 1 means that the value is 0, probability is 0. Larger 2 means that 2 pairs 2, 1, 2, 2. So, the probability 2 by 36. Larger of the pair is 3 means that only the pair 2, 3, that is 1 by 36. 2, 4 means that only the pair 2, 4, and the probability 1 by 36. 2, 5 means that the larger is 5 means that only the pair 2 5, so 1 by 36. Only the pair 2 6, so 1 by 36. Okay, now what about x takes the value 3, that is we have to consider the third row of the sample space, and hence the larger of the values is 1 doesn't exist, that is probability 0. Here also the probability 0. What is about the larger 3, that is for 3 1 3 2 3 3, the larger is 3, so it is 3 by 36. I hope you follow me. And 3 4, that is larger is 4 means that only 3 4 is the pair, so 1 by 36. Only 3 5 is the pair, it means that y equal to 5, that is again 1 by 36. Only 3 6 is the pair, since y equal to 6, that is the probability 1 by 36. Now fourth x equal to 4 means that fourth row of the sample space, that is larger is 1 doesn't exist. Here also 2 3, and what about the larger is 4 means that for the pairs 4 1 4 2 4 3 4 4, the larger of the numbers is 4, that is here the probability 4 by 36. Okay. And here only 4 5 is the pair for which larger is 5, that is 1 by 36. And here for only 4 6 it is the larger is 6, that is again 1 by 36. Okay. And for the larger is 1. For the fifth row larger is 1, it doesn't exist, that is all these probabilities are 0. And what is about the larger of the numbers is 5, it is for 5 1 5 2 5 3 5 4 5 5, that is it is 5 by 36 the probability. And only 4 5 6, the larger is 6, 1 by 36. Now for the sixth row, x equal to 6 means that 6 1 6 2 6 3 6 4 6 5 6 6 are the pairs, so that larger one doesn't exist. All these takes the value 0 probabilities, and the last one is 6 by 36. Okay, 6 by 36. Now we have to obtain the marginal distributions. Okay, what is about marginal distribution? It is 6 by 36. F1 next. Okay, here 2 plus 2, 4 plus 2, 6 by 36. All these values will be 6 by 36. Okay, check. Yes, it is correct. All these values will be 6 by 36. Now what about F2y? F2y, it is only 1 by 36. We know for the probability, for the pair 1 1, the probability is 1 by 36. Then 2 1 plus 2, 3 by 36. Then 1 1 3, that is 5 by 36. Then 1 1 3 plus 4, 7 by 36. Then 1 2 3 4 5, 9 by 36. Okay. Yes, it is 1 1 2 plus 1 3 plus 1 4 plus 1 5, it is 11 by 36. That is, we have F1 x equal to, I have already mentioned, defined F1 x equal to sigma over y, f of x y, and F2 y as equal to sigma over x, f of x y. And here we have asked whether x and y are independent. Let us check. 6 by 36 into 1 by 36, it is not equal to 1 by 36. Okay, that is F1 of 1 into F2 of 1 equal to 6 by 36 first row total into first column total 1 by 36. It is not equal to F of 1 1. Okay, that is this probability, that is x and y are not independent. X and y are not independent. What's the reason? Since x and y are not independent, since f of xy not equal to f1 x into f2y. that is f1x into f2y not equal to f of xy for all xy. So that x and y are not independent. Okay. Yes, thank you.